October 13, 1942. The waters off Cape Esperance shimmer black beneath a moonless sky. The USS Helena cuts through the Solomon Sea, her hull slicing the dark Pacific into twin trails of phosphorescence. On her bridge, young radar operators stare into a green glowing screen, a window into an invisible world. The night smells of salt and diesel fuel. In the distance, unseen, a Japanese cruiser column approaches at 28 knots, their commanders confident in the darkness that has always belonged to them. For 3 centuries, naval warfare had obeyed one immutable law. He who saw first, struck first. And in the blackness of tropical nights, in the rain squalls and the smoke of battle, seeing meant eyes, human eyes, trained and keen, straining against the dark. The Imperial Japanese Navy had perfected this art. Their sailors consumed special diets rich in vitamin A. Their officers trained for years in night optical recognition. They had developed the long lance torpedo, a weapon designed for battles fought in darkness, where surprise was doctrine and invisibility was strength. From Pearl Harbor to the Java Sea, Japanese forces had demonstrated a terrifying mastery of nocturnal combat. American sailors feared the night, and with good reason. In the dark waters off Savo Island just 2 months earlier, for Allied cruisers had been sent to the bottom in less than an hour. American lookouts never saw what killed them. But on this October night, something fundamental had shifted in the physics of war. The American sailors aboard Helena and her sister ships possessed a tool their enemy could not see and did not yet understand. It was not elegant. It was not refined. The SCR-270 and SC radar sets that American vessels carried were bulky, temperamental machines that broke down in tropical humidity and required constant maintenance. German and British radar technology was in many ways more sophisticated, more precise, more advanced in theory. But American radar had one quality that transcended elegance. It worked. More importantly, it was everywhere. While other nations treated radar as a scarce resource for capital ships and critical installations, American industry had already begun mass-producing these electronic eyes. By late 1942, radar sets were being installed on destroyers, cruisers, even PT boats, not as experimental equipment, but as standard armament. The United States had democratized technology itself. The Japanese commanders approaching Cape Esperance expected what they had always encountered: hesitation, confusion, the natural fog of war amplified by literal darkness. They expected to close to torpedo range unseen, to deliver devastating strikes before American forces could organize a response. They had planned this battle according to the ancient rhythms of night combat, visual sighting at perhaps 6,000 yards if conditions favored it, then the deadly dance of searchlights and torpedoes. Helena's radar painted them at 27,000 yards, more than 13 miles away in utter darkness. The Japanese task force appeared on American screens as clearly as ships in daylight. Range, bearing, speed, information that would have been impossible to obtain through optical means now flowed continuously to American fire control stations. The technological gulf was not merely one of capability. It was one of entire tactical dimensions. The Japanese Navy was fighting a 19th century battle, while American forces operated in a realm their opponents could not perceive. Lieutenant Commander Roger W. Simpson, analyzing the engagement afterward, would write with careful understatement, "The value of radar in night surface engagements cannot be overstated. It provides not merely an advantage, but a fundamental transformation of the tactical environment." What he meant, what every American sailor who survived these encounters understood, was simpler and more brutal. They could see, and their enemy could not. The battle lasted 24 minutes. American guns, directed by radar, opened fire at ranges Japanese commanders believed impossible. The heavy cruiser Furitaka, struck repeatedly by shells she never saw coming, began listing within minutes. The destroyer Fubuki exploded and sank so quickly her crew had no time to abandon ship. Japanese searchlights stabbed desperately into the darkness, seeking targets their gunners could aim at, revealing only their own positions to American radar-directed fire. It was not a battle. It was an execution made possible by electrons and cathode ray tubes. But Cape Esperance was merely prologue. In the narrow waters between Guadalcanal and Florida Island, a channel sailors would soon call Iron Bottom Sound for the number of ships resting on its floor. The night battles escalated. November 13th. The battleships USS Washington and South Dakota engaged the Japanese battleship Kurashima. November 30th. The Battle of Tassafaronga, where even in tactical defeat, American radar provided warning that saved multiple ships from complete annihilation. Each engagement followed the same pattern. Japanese forces, supremely confident in their night fighting prowess, pressed attacks, expecting confusion and chaos. Instead, American guns found them in the dark with mechanical certainty. The symbolic weight of this transformation cannot be understated. The radar scope itself, that circular green screen with its sweeping arm painting ghostly images of distant ships, became an emblem of American industrial philosophy. It was not beautiful. It lacked the aesthetic grace of a Zeiss optical sight or the craftsmanship of a Japanese range-finding telescope. But it embodied something more powerful than elegance, abundance paired with pragmatism. While Axis engineers pursued theoretical perfection, American factories pursued production. While others refined, America replicated. By war's end, the United States would produce radar sets not by the hundreds, but by the tens of thousands, enough to equip Liberty ships, landing craft, even individual fighter aircraft. Japanese naval officers, when interrogated after the war, spoke of those night battles with something approaching disbelief. Captain Tamichi Hara, one of the few destroyer commanders to survive the Solomons campaign, recalled, "We thought ourselves masters of night battle. Then came engagements where our enemies fired accurately in complete darkness, where our approaches were detected at impossible ranges, where our carefully rehearsed tactics collapsed before we could execute them. We were fighting an enemy who could see in the dark, and we had no counter." The psychological impact rivaled the tactical one. Japanese night fighting doctrine, built on centuries of naval tradition and years of intensive training, had been rendered obsolete by a technology they possessed, but had failed to mass-produce and deploy. The humiliation was doctrinal. Their warrior spirit, their superior training, their sacrifice and dedication meant nothing against an opponent who had industrialized perception itself. The green glow of the radar scope illuminated more than enemy ships. It illuminated a fundamental truth about modern warfare that would reshape the remainder of the 20th century. Information dominance matters more than individual valor. The American victory in the Pacific's night battles was not won primarily by braver sailors or better tactics. It was won by engineers in laboratories and workers on assembly lines who had transformed theoretical physics into practical tools, then flooded the fleet with them. Quantity had achieved a quality all its own. The radar operators who stared into those screens night after night, tracking Japanese vessels through rain and darkness, represented a new breed of warrior. Men who fought not with their eyes, but with their minds, who killed enemies they never saw with their own eyes by guiding guns they never personally aimed. It was antiseptic in a sense, divorced from the immediate, visceral reality of combat. Yet it was absolutely lethal. The democracy of technology meant that a 20-year-old technician from Iowa, after a few weeks of training, could perceive tactical reality more clearly than a Japanese admiral with 30 years of experience. Expertise itself had been democratized, mass-produced, distributed like ammunition. The moonless nights over Iron Bottom Sound eventually gave way to dawn, as all nights must. But the lesson written in the wreckage of Japanese warships on the Solomon seabed outlasted the war itself. Technology, when married to industrial capacity and deployed without reservation, does not merely provide advantage. It redefines the possible. The green glow of the radar screen became a symbol of American power more profound than any battleship or bomber. The power to produce abundance, not just of material goods, but of capability itself. In the democracy of American warfare, every ship could see in the dark, every crew could strike with precision, and the night, ancient refuge of the stealthy and the brave, belonged now to those who had industrialized omniscience. The Japanese had trained their sailors to see in darkness. America had simply turned on the lights.